Alright, so some special quadrilaterals. We've already talked a little bit about parallelograms, but we're going to touch on all of them now. So a quadrilateral is any polygon with 4 sides. Some quadrilaterals have some special properties. Parallelograms, which we've talked about, trapezoids, kites, rhombus, rectangle, and square. Those are all special quadrilaterals that we're going to be talking about today. Alright, so the relationship between the different quadrilaterals can be modeled like a family tree. So if we take a look at this model right here, we've got quadrilaterals at the top. Kite is a quadrilateral, directly connected. A parallelogram is a quadrilateral, and a trapezoid is a quadrilateral. Rhombus and rectangle are both parallelograms, which are quadrilateral. And a square is both a rhombus and a rectangle. It shares all the properties. This family tree, if you can memorize how this goes, you're going to be asked a lot of questions about sometimes, always, and never. If you're going straight down, if you start with quadrilateral and ask, is it a rhombus, based on given information, a quadrilateral is sometimes a rhombus. So down, it's going to mean sometimes. If you're going up, is a square a rhombus? Well, that's always. If you're going from square up, is a square a parallelogram? Always a parallelogram. So up is going to mean always. If you're going side to side, is a kite a parallelogram? Is an isosceles trapezoid a kite? Side to side is never. So down is sometimes, up is always, side to side is a no-no. Alright, so in the family tree model, each shape has all the properties of the one above it. So here are the properties for each shape. A parallelogram, we've talked about these. 2 sets of opposite sides are congruent. 2 sets of opposite sides are parallel. 1 set of opposite sides are congruent and parallel. Opposite angles are congruent. Diagonals bisect each other. Consecutive angles are not congruent, but supplementary. Okay? For a rhombus, it has all of the properties of a parallelogram because it's below it. But in addition to all of those, it has all the sides are congruent to each other and diagonals are perpendicular. A rectangle has everything above a parallelogram, or has everything of a parallelogram because it is one. But all of the angles are 90-degree angles, and the diagonals of a rectangle are always congruent. Now a square has all the properties of rhombus and rectangle and parallelogram because it's directly below all of those. So all the sides are congruent, but the diagonals are also congruent. Diagonals are also perpendicular, it gets that from rhombus, and all the angles are 90 degrees, it gets that from rectangle. Now a trapezoid has exactly 1 pair of opposite sides that are parallel. That's all the special properties of trapezoid. 1 set's parallel, the other set's not. An isosceles trapezoid, however, the base angles are congruent and the diagonals are congruent. What makes the isosceles trapezoid isosceles is that the sides that aren't parallel have the exact same length. Kind of like an isosceles triangle that's had the top cut off of it. Alright, so a kite, there are no sets of sides that are parallel, but it has 2 sets of consecutive, not opposite, consecutive sides that are congruent. So the top 2 are congruent and the bottom 2 are congruent, for example. And the diagonals of a kite are always perpendicular. So you're going to be asked questions that really test your knowledge of the properties. The directions will often help you know which properties to be mindful of. So for example, in the following rhombus, find x and y. Well, if you're given the fact that it's a rhombus, you need to start thinking about the properties of a rhombus, which are that all the sides are congruent and that the diagonals are perpendicular. Well, if all the sides are congruent, you can take these 2 sides and set them equal to each other and find that x equals 10. Even if this 3x minus 3 were up here, you could have set them equal to each other because all 4 sides of a rhombus are congruent. It's like a square that's been kicked at the top and made to lean. Alright? To solve for y, all you have to do is set 2y equal to 90 degrees because we know that the diagonals of the rhombus cross at 90-degree angles because they're perpendicular. So when you do that, you find that y equals 45. Another example, if you're given that ABCD is a parallelogram, find the perimeter. Alright, so now we're going to need to write 2 equations based on the properties of parallelograms. If we take a look here, I've got 3x minus 4 and 2x plus 1. I can set those equal to each other and find that x equals 5. I can also set my 3y plus 14 and 5y plus 6 equal to each other and find that y equals 4. But it's not asking you to solve for the variables, it was asking you to find the perimeter. Perimeter is what you get when you add up all the sides. So all I need to do is plug the 5 back into either one of these and then multiply that times 2. I need to take the 4 and plug it back into either one of the y's and multiply that number times 2 as well, because I get 11 and 11 for this side over here, that's the shorter side, and then 26 plus 26. When I add them all up, the perimeter is 74 units. Alright, so here's some examples of when you're going to be asked to use the properties of special quadrilateral to determine if the statements are sometimes, always, or never true. So a square is a rectangle. So I started at square. We go back and look at our family tree. I start at square and go up to rectangle. Up means always, so that's always true. A parallelogram is a square. I started at the top at parallelogram and looked down to square, so it's sometimes true. A square is a parallelogram. Again, I started at the bottom and worked my way up, so that's going to be an always. A square is not a rhombus. Well, a square is always a rhombus, so that statement is never true. A trapezoid is a parallelogram. That would have been going side to side. That's never true. The little exception to this rule is a rhombus is a rectangle. And I have to use sometimes, but it's not really sometimes, it's only one time. When the rhombus is a square, it is also a rectangle. That's the only exception to the side-to-side rule. When a rhombus is a square, it is also a rectangle. So when it has all four sides congruent and all the corners are exactly 90 degrees, that is when the square is both a rhombus and a rectangle.